In this particular case, oh gosh, I don't want to divide by 17. And up and down baxis. And that's going to be interesting. What is going on? Does indeed equal 12. That's negative 24. That's positive. Oh, no, it doesn't. Welcome to today's Math Minute, the only Math Minute guaranteed to be no more than 10 minutes long and guaranteed to be today. Haven't done one of these in about a week. I told my students the other week, I'm a teacher by day, and I told my students I just got nothing. I had no mathematical inspiration. So, of course, like 17 things have happened since then, and now I have some ideas for what to talk about. First of all, if you didn't already know, this is the third in a series of 5 videos where I am following my social media interns' requests, my social media team, to do a giveaway. Nice iPhone 8 box. So if you would like to be in possession of that box, I might even sign the box. Like and subscribe, comment down below. I will do a video after the 5th of this series of videos where I'll show you how I build an Excel spreadsheet that will randomly choose among the videos and randomly choose among the comments to find a winner for that sweet iPhone 8 box. I don't even know what's in that box, so whatever's in that box is yours. I'm not opening the box. I won't find out. You'll be the first to find out what's in the box.
What's in the box?
So I want to talk about a form of a linear equation. So a linear equation, usually what we mean by linear equation is something in 2 variables without any powers that when we come up with solutions for that equation and then we graph those solutions, it makes a line. And so the most common, I don't know about most common, but the form that students typically dread when they're in 7th or 8th or 9th grade is what we call y equals mx+ b. This is also known as slope-intercept form because the m is our slope and the b is our y-intercept. There are other forms when you get to calculus later on. The form that you use more regularly is called point-slope form. Y minus y1 equals m times x minus x1. And so again, that one is called point-slope form because it comes from a slope m and some point x1 comma y1. So if you know just a slope and any point, not just the y-intercept, you can plug it into this point-slope form. Again, the slope goes there, and then the x1, y1 would be that point that you plug in your x and y coordinate for. There is also something, I don't know if this is international, but Americans definitely learn about this thing we call standard form, which is Ax plus By equals C. So this is the form that you would typically use if you were doing, like if you were about to set up matrices, if you're doing matrix solutions to a linear system. This is also typically the format that we use when we are taking word problems and creating our own equations. The A, the B, and the C, they don't stand directly for any quantity like slope or y-intercept or any particular point. And so usually what I tell my students is these are just parameters. And as we change the parameters, we're going to change what the graph of the equation looks like. C ends up controlling the y-intercept. I guess both the x and y-intercept, if you think about it. A and B end up being related to the slope. But again, they're not related directly. And so usually what we do is we get an A and a B and a C from some kind of description in a word problem. Like you can imagine something saying, oh, jeans cost $4 per pair, and then t-shirts cost $3 per pair, and we have $12 to spend. How many combinations of jeans and t-shirts can we buy? We usually generate this kind of equation when we're solving those sorts of word problems. But there's a form, I'm not going to say that I'm definitely not inventing this, I'm not the one who came up with this, but it is a form that I don't see as often, and again, I'm sure I'm not the first to ever call it this, but I call it intercept form. And we could take something like this 4x plus 3y equals 12. And if we decided, you know what, let's actually kind of normalize this in some sense. Let's make this number over here 1 every single time. So obviously, since it's actually 12 right now, what do? We divide by 12, and that's going to turn it into 1. We end up with x over 3 plus y over 4 equals 12. And that's going to be interesting for a reason that I show you right now. So let's consider that first equation, 4x plus 3y equals 12. What would we do if we wanted to graph 4x plus 3y equals 12? Well, we would need to come up with some ordered pairs that satisfy the equation, right? That when we plug them in, actually make it true. So one such ordered pair is 6, -4. Because when I multiply 4 times 6, I get 24. 3 times -4, I get -12. And 24 plus -12 really is positive 12. So 6, -4 is one point that goes on this line. Some other points that end up working, 3, 0. And so if I plug in 3 for x and 0 for y, the same thing ends up happening. It works out to 12. Other pairs that would work, so what is it, 1.5, 2 ends up working here. If we multiply 4 times 1.5 and 3 times 2, we get 6 plus 6 equals 12. So what we would do usually is take these points and we would put them together and draw a line going through the different points. That line would look something like that. Typically what a teacher is going to ask once we've got our graph of the line are things like what's the slope of the line, but also things like what are the x and the y-intercepts of the line. Now you might notice we already have the x-intercept, right? An intercept, of course, is just where the line crosses one of our axes. X-intercept is where the line crosses the x-axis. Y-intercept is where the line crosses the y-axis. You can tell this point right here, 3, 0, was our x-intercept. You might also be able to tell pretty easily that 0, 4 was the y-intercept. And you might notice those numbers popped up in this form, but they kind of appear like they're in the wrong location. The x-intercept was the one associated with 3, but over here the 3 is in front of the y. The y-intercept was associated with 4, but over here the 4 is in front of the x. If I had taken that form, though, and used the normalized form that I showed you, where we divide everything by 12 to get a 1 over on this side, it just so happens that we end up with x over 3 plus y over 4 equals 1. And then that ends up making it so that what we want associated works out. The y-intercept gets associated with 4. The x-intercept gets associated with 3. And that's not a coincidence. That's going to happen no matter what. The reason it happens is that, of course, for the x-intercept, when we want the line to be crossing the x-axis, we won't have moved up or down from the x-axis. The y-coordinate is the one that tells us how to move up or down. And so if we're not moving at all up or down, that means the y-coordinate is 0. When the y-coordinate is 0, it gets rid of this part of the equation, and we simply have x over 3 equals 1, and obviously that's going to end up being true, where our numerator and our denominator match. And so that's why 3, 0 is the x-intercept. We can imagine the same thing for the y-intercept. What we want for the y-intercept is for x to be 0 instead, because now we're crossing the y-axis. If we're on top of the y-axis, we have not moved to the left or right at all. Left or right is about our x-coordinate. Not having moved at all means x equals 0, and so this part turns into 0, and we're simply left with y over 4 equals 1, which in this particular case means that y is 4. And there it is, 0, 4. So what could I do with this? Imagine that I have any standard form line. So something like 5x plus 2y equals 20. I'm going to normalize this, which what I mean by normalize is I want to get a 1 over on that other side. And so that ends up giving me x over 4. Once I simplify here, 5 goes into 24 times, plus y over 10 equals 1. Having it in this form immediately tells me the x-intercept is 4, 0, and the y-intercept is 0, 10. So this is a really useful form. Just looking at it immediately gives me information. In fact, we could state this in general. X over a plus y over b equals 1. If we call this our intercept form, it is always going to have an x-intercept of a, 0 and a y-intercept of 0, b. Of course, all the examples I've used happen to have used integers, and there's no special reason that it has to come down to an integer. Let's say I had 5x plus 3y equals 4. Yeah, let's say 4. I would divide everything by 4. Now, if I just simplified from here, I would end up with 1.25x plus 0.75y equals 1, but that doesn't help me because I needed a denominator. Fortunately, I can just use reciprocals here. 5/4 x is the same thing as x divided by the reciprocal, 4/5. or x over 0.8. 3/4 times y is the same thing as y divided by 4/3, or y over 1.3 repeating. And then it equals 1, and there you have it. My x-intercept is 0.8, 0. My y-intercept would be 0, 1.33. There's another reason I find it interesting that we don't teach this to, 7th, 8th, 9th grade students, because this equation right here, x over a plus y over b equals 1, if you are in, say, 9th or 10th or 11th grade, you probably recognize as being very closely related to some of our conic sections. In fact, if we just square these so that we get x squared over a squared plus y squared over b squared equals 1, we end up with an ellipse in the coordinate plane. We have a left to right axis where a gets us our distance from the center to the edge of the circle. We have an up and down axis where we go b distance from the center to the edge of the, I said circle, but I meant ellipse. And in fact, we could even extend this. We could say something like, x minus h squared over a squared plus y minus k squared over b squared equals 1, where now we have a center of the ellipse at h comma k. And so one challenge I'm going to leave you with today is, what would it mean to take that back and fill it into this intercept form I'm giving you for a line? In what sense does a line have a center, right? What would it look like if we have x minus h over a plus y minus k over b equals 1? What does it matter to have a center of the line? Is the center of the line a point on the line? Because the center of the ellipse is not a point on the ellipse, right? So that's a question I'm going to leave you with. Anyway, I hope that's been kind of interesting to you today. Another form of a linear equation, not one that's very commonly taught, but one that I think is particularly useful. Be sure to like and subscribe if you would like some more Math Minutes, more information like that. Leave a comment if there is some topic you would like me to cover on a future video. I'm happy to put that together. And otherwise, have a great afternoon, evening. I will see you in the next one.